All right, so this is a video regarding solutions of ionic equilibrium booklet, and in that particularly for the section of get equipped to JEE Mains. Now, as I have highlighted in the class as well, that the level of these questions are not really similar to JEE Mains. These questions are relatively much more difficult. They are actually kind of advanced level questions if you ask me. But since that is there in the booklet, so let's look at these questions and their solutions one by one. Now, the first question is something which we typically do in our classes, in our lectures only, where we discuss this concept while describing the pH scale. And the pH and pH of pure water comes from this self-ionization equilibrium. And what we understand is that for increasing temperature, the Kw value increases, which shifts the equilibrium in forward direction, which increases the concentration of both H plus and OH minus, and hence the value of pH and pOH both become lower. Hence, the option here would be the correct answer. Now, second question is a relatively difficult question. It is something which requires you to actually, read multiple times so as to be able to comprehend what is exactly happening in the question. Now, if you try to break it down in a step-by-step manner, when it says 0.1 mole of cadmium sulfate is present in a solution. So cadmium sulfate, as you can see, neither KSP is given nor being asked. So we'll take it to be a soluble salt. And as a consequence, I can comment upon how much cadmium ions and sulfate ions are there. Now, why have I done that? Because you can see later in the question, cadmium ions are featuring. So that is something which we understand is given information. Then it is also mentioned that the solution also contains HCl, and the concentration of it was given as 0.08 normal, which you could also replace as 0.08 molar. Now, based on that, again, the amount of H plus and Cl minus ions in the solution can be easily figured out. Now, it is saying that H2S gas is passed to precipitate all cadmium ions. How does that happen? H2S combines with cadmium to form cadmium sulfide salt. Now, where did I get that hint from? Well, that is again not something which was specified in the question very clearly, but because it's a cation, cadmium 2 plus, it has to be precipitated by an anion. So H2S में the anion is sulfide ion, right? So cadmium 2 plus combines with that sulfide ion to form this cadmium sulfide salt. And as a consequence, more H plus gets released in the solution. Now, how much of that comes in the solution? We can quickly do that calculation because all of the cadmium 2 plus ion is getting consumed. So say excess of H2S was bubbled in. As a consequence, that 0.1 mole of cadmium precipitates and 0.2 mole of H plus got released into the solution. So if I am now calculating the pH, the total H plus in the solution, as we can see from here, right? 0.8 was already there and 0.2 ml got introduced. So 1 millimole or 0.8 millimole was already there and 0.2 millimole got introduced because of that precipitation reaction. A total of 1 millimole of H plus is there in 10 ml solution. And now, as per the question, the solution is diluted to 100 ml, right? So it is diluted to 100 ml by adding water. Hence, the H plus concentration becomes 1 divided by 100 molar, or you can say the pH becomes 2, right? Next question, third question is again something that requires a little bit of clarification. Now, this clarification comes from looking at that small quantity of zinc was actually required. Right. So, in this question, when we talk about the small quantity of zinc salt that is being mixed with the ammonium sulfide solution, and as a result, it is asking how much zinc 2 plus remains unprecipitated. Now, the question did not mention small quantity of zinc salt is being added, but that is important. We'll see how. See, the zinc salt will give Zn 2 plus ions, and the ammonium sulfide salt, as you can see, ना तो इसका KSP दिया जा रहा है ना पूछा जा रहा है, right? Neither the KSP is given nor it's being asked. So we'll consider it to be a soluble salt, and as a consequence, you see S2 minus ion concentration. And as per the data given in the question, zinc sulfide precipitate can be formed, and that is what the reaction will be. Now, the reaction will be almost 100% forward, right? Because 1 upon Ksp will be a small value. So what you need to know over here is that say if some small quantity of zinc 2 plus salt was added initially, and this was 0.021 molar initially, then zinc 2 plus ion almost is completely consumed. Some small quantity is going to be remaining that we have to calculate. And sulfide ion will be 0.021 minus A. But as I said, because it's a small quantity of zinc 2 plus ions that we have added, we can neglect that and consider the sulfide ion to be still 0.021 molar only. That you can then substitute in the Ksp expression to calculate how much zinc 2 plus ion concentration is remaining in the solution, and then accordingly calculate the mass of Zn2 plus ion that is remaining. Right. So this small quantity of zinc salt was required to be mentioned. Then you have the next question, which talks about a buffer solution being prepared of ammonium sulfate and NH4OH. So it's a weak base and its conjugate weak acid. You can say it's salt with strong acid. Now, if you remember, the stoichiometry plays an important role, and the formula for such basic buffer is POH is equal to PKB, like PKB of the weak base plus log salt upon base, and that salt is actually this conjugate weak acid part only. So यहाँ पर notice करना stoichiometry का role is important because twice the moles of the salt will be actually the NH4 plus concentration. So you substitute here the salt concentration as say 2x, because say x is the moles of the salt, and of course divide by the volume so that you can use it in the expression. The pH value is given and the pK value of NH4 plus is given. Right. So the pKb will be 14 minus pK of NH4 plus. Okay, next question talks about what is the percentage hydrolysis of NaCN and N by 80 solution. N by 80 is 1 by 80 normal, but as I said, you can still consider here 1 by 80 molar would also work. And you are being asked what is the dissociation constant. Dissociation constant stands for Ka, right? So it's a weak acid solution, a strong base weak acid salt solution. And you are being asked about the dissociation constant. Yahan par actually, I have actually calculated the hydrolysis, degree of hydrolysis, but the dissociation constant of KCN is this Ka. Right? Oh, no, sorry, my bad. It's not the dissociation constant that is being asked, it's the percentage hydrolysis that is being asked, right? So it is H only. And of course, if you have to mention it in percentage, right? So this value, whatever you got from here, multiplied by 100, you report it in percentage terms. Right. So the scenario that you have is strong base, weak acid, salt, or you can say a weak base. Cn minus is a conjugate weak base. Right. So alpha, or you can say degree of hydrolysis, should be equal to under root of KBC, but since KB is not given, we can write it as Kw upon Ka of HCl. Right. So you are given Kw value, you are given Ka value, you are given the concentration, you substitute all of them and calculate the value of H. Now, next question talks about the concentration of fluoroacetic acid, which is required to get H plus concentration this much. Now, by looking at the question, identifying the scenario, we say it's a weak acid solution, and H plus is equal to root KAC is the formula to go for. However, the question data is actually such that you also should check for the approximation of alpha, because the formula are only valid when both the approximation of weak acid are valid. So as soon as I do that, I realize that alpha is not much less than 1. Hence, you should not use the formula. You should go for the basics, write down the equilibrium of the weak acid, HF giving F minus plus H plus, and then you can use K is equal to C alpha square upon 1 minus alpha, and H plus concentration is equal to C alpha. So we got two equations and two unknowns. You can solve for alpha and C. Right, so you'll get the concentration. Then the seventh question talks about the number of H plus ions present in 10 ml of solution of pH 3. Now that is something which is again straightforward question. pH diya hua hai, so you know the H plus concentration, the volume is given to you, so you can calculate the moles of H plus that are there, and then from that you can calculate the number of H plus that are there. Eighth question is a very easy question, classic question regarding simultaneous precipitation. So you have to realize that NaCl and Na2CrO4 are going to be soluble salts, and you are going to get Cl minus and CrO4 2 minus concentration based on that. Now Ag plus is being added in a slow and gradual manner, so the ion or the anion which will get precipitated first is the one which requires the least amount of Ag plus. So you can apply the condition of precipitation for both these ions one by one and get the amount of Ag plus that is required for precipitation. Don't forget about the stoichiometry, that plays an important role. And based on that, we see that the moles of Ag plus required for chloride ion will be lesser, and hence the Cl minus ions will precipitate first. Ninth question is a good question. It's a tricky question, but something similar to what we have done in class only. So you are being asked what will be the pH of a 0. Oh no, so okay. Sorry, I mistaken it for a different question. That's going to come in upcoming discussion. This is actually a very easy question. It's just a polyprotic weak acid solution, and you remember the formula is H plus equal to root K. So you just put the values and get the answer. The approximations, if you want, you can check. They are going to come as valid approximations. The 10th question is something similar to how we have done the self-ionization of water. So in this case, instead of water, you have pure formic acid, right? So that pure formic acid undergoes self-dissociation or self-ionization in the following manner. You have the following equation representing that self-dissociation or self-ionization. Now, in this, when we write it down in detailed manner, you can see I can write C and 0, 0. Now, this concentration of pure formic acid is something similar to how we have determined concentration of pure water, right? So let's say we took 1 liter of formic acid. 1 liter meant the mass of formic acid was 1220 gram, because the density is given as 1.22 gram per centimeter cube. So this is the mass in grams, and then you divide by the molecular weight to get the moles. And since the volume was 1 liter, this is the concentration of pure formic acid. Right, so you write C1 minus alpha, C alpha on the right hand side, and you write the expression of the equilibrium constant. Now, since we remember simplifying this, how we did in case of self-ionization of water, so we follow the same steps. This C1 minus alpha can be taken to the left hand side and merged with K equilibrium, and that is what we call as Ka. Acid dissociation constant of formic acid. Then another C from the denominator can be taken on the left hand side, and that merged with K, given that alpha is much less than 1. Well, it's not given actually. We are taking that approximation and we'll validate that as well. So this K into C can be called as K ionic product. How you used to write for water, KW. For water, it used to be H plus into OH minus, or you can say H3O plus into OH minus. For pure formic acid, it is in the following manner: HCO H2 plus H into HCO minus. Now, given this ionic product value, you get the value of C alpha, and based on that, alpha comes out to be 10 to the power of minus 3 upon C, and that C value we wrote just above some time back, 1220 upon 46. So we will get the value of alpha. Of course, if you have to report in percentage terms, we multiply by 100 and then report in terms of percentage. Now, next question is a very, very easy question. It's a simple strong acid plus strong base mix. When you analyze them, you have to do millimolar analysis and accordingly get the final answer. Right. The only thing tricky here was, instead of giving you directly concentration of these strong acid and strong base, the pH and the pOH values were given, which can be used to actually calculate the concentration of H plus and OH minus to begin with. Of course, don't forget to do analysis in millimoles. Don't forget to ensure that the final volume is being used when you are writing the final concentration. So all those careless mistakes need to be avoided, and you will be able to solve the question very easily. 12th question is something which I have asked you to skip because it involves this concept of rate constant, which is to be taught in chemical kinetics. Now, as a just for the sake of completion, let me just elaborate it for someone who has actually done chemical kinetics would be able to relate to this. Now, the language of the question is also pretty difficult because it's quite confusingly worded question. It is saying ionization constant of NH4 plus in water. So it is basically hydrolysis of NH4 plus in water, right? That is given to you, and its equilibrium constant is given to you as this value. Now, what is being asked in the question is rate constant for proton transfer from water to ammonia. Now, that kind of is in relationship with also what is given as rate constant of the forward reaction, like NH4 plus plus OH minus, right? This is the reaction. So this reaction can be achieved by adding the self ionization of water in a reverse manner. So you get this NH4 plus plus OH minus giving NH4OH. And based on that, because we added these equilibriums to get the third equilibrium, so the third equilibrium constant is actually multiplication of the above two. And from chemical kinetics, we understand that this equilibrium constant is equal to rate constant of the forward direction upon rate constant of the backward direction. These small k's, they represent rate constants. Right? So K forward, like NH4 plus plus OH minus giving NH4OH, that is given to you. The backward is being asked that how much or what will be the rate constant for proton transfer from H2O to ammonia. Right? This reaction going in the backward direction. So using that knowledge, that equilibrium constant is rate forward upon rate backward, or you can say K forward upon K backward, we get the K backward value. 13th question is very easy. We have done something similar to it in the class only. So 1 liter of water contains 10 to the power minus 7 moles H plus. And it's being asked what is the degree of ionization of water. So we say the degree of ionization of water is or can be written in the following manner: C00, C1 minus alpha, C alpha, and C alpha OH minus. Or यहाँ पर we can use that H plus concentration because it's directly going to use C alpha. You can get the value of alpha by dividing 10 to the power of minus 7 by C. C was, as you can see, we have done it in class many times also. It is 1000 by 18 molar. Then the 14th question is all about identifying the compound, which category do they belong to, and subjectively trying to take a guess of whether the pH is going to be more than 7 or less than 7. And that gives you a very clear picture in terms of how the pH of these species would be in an increasing order. 15th question was that question which I was talking about, is a difficult question for hydrogen sulfide, right? So here it is being asked about the S2 minus ion, the sulfide ions in the H2S solution, which has a pH of 1, or you can say H plus concentration of 0.1 molar. Now, we all know that given the H2S ka concentration, given Ka1 ka values, this is not achievable for pure play H2S solution. So there is something else that is also present in the solution that is making the solution so acidic that H plus concentration is 0.1 molar. That's fine. And we have done such similar questions in the class where the pH value has already been done, the H plus value concentration has been done or given in a very set of easy steps, and some other ion concentrations are being asked. In that case, if you remember, the approach that I told you in the class was to use the equilibrium constants, their expressions. So here we use the equilibrium constant expressions K1 and K2, and we find that if I multiply them, Hs minus cancels out, and the given terms are there, are quite clearly mentioned in the question. The one which is not there is supposed to be found out. In this way. Then the 16th question is relatively easy. It's just simply talking about a buffer solution made up of weak acid and its conjugate weak base, or equal moles mein hai, so you can say the POH will be equal to PKB of the weak base plus log salt upon acid, because they are in equal amount, that log value comes out to be 0. So you can just simply say that POH will be equal to PKB, hence the pH value will be just 4. So that's the simple explanation for the 16th question. 17th question is very similar to the question that we had done some time back, where we explored formic acid and uska ionic product. So यहाँ पर we are exploring ammonia and uska ionic product. So the kahani goes in the same manner. You have ammonia, self-ionizing into NH4 plus and NH2 minus ions. You can analyze it, make sure that you simplify the equilibrium constant by merging constants with it, and eventually come out to this K ionic product, which is C alpha into C alpha, or you can say concentration of H plus into NH4 plus and NH2 minus. Now, given that NH2 minus concentration in this case will be equal to under root of K, that ionic product, we use that value and then determine the volume and or given the volume and determine the moles of the, or number of NH2 minus ions that are present in the solution. 8th question is quite straightforward. Only careless mistake which you might have made is that mixing is the catchword, because the concentrations, these are given before mixing. So you'll have to use the after mixing concentrations while putting the condition for just precipitation, which is QSP equal to KSP. Of course, don't forget about the stoichiometry. These coefficients are going to run in the parts. 19th question is a slightly tricky question, because we haven't done much about indicators apart from understanding how they work and remembering some of their names and their colors. How an indicator is going to work in this particular question, you can simply understand that the indicator also establishes its own equilibrium with the other species that are present in the solution. So the H plus concentration which is going to be there in the solution, in this equilibrium, is going to be common with the entire solution. So apart from that, if you notice the equilibrium, if there was some initial amount of HIN present and some part of it dissociated to form ion minus, the concentrations of HIN and ion minus are going to be complementary of each other, right? So You can say if this is X%, then that will be 100 minus X%. And since the equilibrium expression is going to hold true, we can write that KIN is equal to H plus into ion minus upon HIN. Given the H plus concentration, you can compute the value of percentage or the relative ratio of these, red species and blue species, the acidic form and the basic form. Then the 20th question is again very standard simple question of how ionic equilibrium questions are. Something plus something is being mixed, so you have to analyze first whether they are going to react or not, and if they are going to react, then you have to perform the millimolar analysis. That's what we do. Go ahead and do that also, and you will find out that's a simple buffer solution that comes in front of you. Of course, be mindful of the kind of formula that you're going to use, because the pH is being asked and it's a basic buffer solution. You're going to use the formula of pOH is equal to pKb plus log salt upon acid. Salt upon base. 21st question is again a straightforward question which talks about this salicylic acid and how it is going to behave in stomach versus how it is going to behave in intestine. Now you can see that stomach is more acidic than the pKa values corresponding to this salicylic acid. So this kind of gives you a hint that inside this stomach, because of the common ion effect, H plus concentration will be more and the equilibrium of the acid will be shifted backward, and as a result there will be less ionization. But in case of intestine, where the pH has become basic, like this equilibrium will have H plus concentration lower, and as a consequence will shift in the forward direction, right? More of the this aspirin acid will get ionized. 22nd question is also a straightforward question. Maintaining pH is all about buffer solutions. So यहाँ पर आपको weak acid HCN and उसके conjugate weak base CN minus के बारे में काफी clear information दे दी गई है. So you have to just apply the formula and get the value of the volume of casein solution that is required. You can of course write concentration by concentration, or you can just simply write moles upon moles, because eventually the volume of the solution is going to be same for both the scenarios. 23rd is a classic complex station equilibrium calculation that we have seen in our solubility of sparingly soluble salts part. यहाँ पर, if I remember, telling you KSP and complex station equilibrium are both to be added and combined and then solved for, and that is this equation that is given us. So this is going to have its equilibrium constant as KSP into KF, and when you simply analyze it in terms of the millimoles or moles, you come up with a very, very easy expression of solving S or A. In this case, S is actually given to you, A is being asked. 24th question is a straightforward question that we have done multiple times in our notebook. Not going to repeat that. Let's move on to the last question of this section, which is about a benzoic acid getting half neutralized. So this term means that NaOH amount that is going to be added to neutralize the acid is going to be half what it is given. And then based on completing the analysis, we realize that's still a buffer solution that is getting formed. So you simply apply the formula of buffer solution that pH is equal to pKa plus log salt upon acid, and then apply, do some small time maths to actually understand what will be the value of K. All right. So that's it. Thank you guys. Take care. Bye-bye.